my name is Paris Akbari, and today I will present our research on the effects of agrivoltaics on residential property values in the United States. Solar energy is one of the fastest growing renewable energy sources in the US, especially through the utility scale solar projects which require large areas of land. While this growth supports clean energy goals, it also raises concerns about visual impacts, ecological disruption, community opposition, and possible declines in nearby property values. Agrivoltaics, which combine solar energy production with food production on the same land, may help address some of these concerns because the land continues to be used for farming. However, although agrivoltaics has been studied for its effects on crop production, water use, and the local climate conditions, its impact on nearby residential property values remain unclear. This leads to our main research question, which is to what extent does proximity to agrivoltaics projects affect nearby residential property values? This study contributes to the literature in three ways. First, it provides national level evidence on how agrivoltaics affects nearby home prices. Second, we developed a new special database of agrivoltaics projects by integrating multiple data sources. And third, we use a large data set of over 2 million housing transactions, allowing us to provide strong empirical evidence to inform policy and community discussions. Our analysis, as I mentioned, combines three main data sources: the agrivoltaics project data, the nationwide residential property transaction, and geospatial datasets. The final datasets include 510 agrivoltaics projects and approximately 2.2 million residential transactions from 2010 to 2024. We use Python-based geographic information systems to calculate distances between each property and the nearest agrivoltaic sites, as well as other features such as roads and the transmission line and the metropolitan areas. To estimate the impact on housing prices, we apply a hedonic difference approach. Properties located within 0 to 3 miles of an agrivoltaics project are considered the treated group, while those located between 4 and 6 miles serve as the control group. We also conduct robustness checks using different distance bands and the subsamples, and we estimate and even study to examine how property values change before and after project installation. Overall, we find no statistically significant evidence that agrivoltaics reduces nearby residential property values. Across the main distance ranges of 0 to 3 miles, the estimated effects are small and not statistically significant. Homes very close to agrivoltaic sites within about a quarter mile show a negative estimate, but this effect is also not statistically significant. And when we look at specific states that has highest number of agrivoltaics projects, such as Minnesota, New York, Massachusetts, and Illinois, the result remain consistent, showing no significant negative impacts. We also explore differences between urban and rural areas. In urban areas, there are no significant effects on property values. However, in rural areas, we find positive and statistically significant effects at distances between 0.5 and 3 miles, which increases of around 3.5%. Finally, the event study shows that the property values follow similar trends before project installation, supporting the validity of our research design. And in conclusion, our findings suggest that agrivoltaics does not negatively affect nearby residential property values. In some rural areas, it may even have a positive effect. And the results indicate that agrivoltaics could be a more socially acceptable form of solar development, helping balance renewable energy expansion with community and land use concerns. Thank you.